All right, Pre-Calc Basics X, the Trig Edition. So the first question, what does this thing simplify to? That's kind of scary, isn't it? I don't know how I should approach this. Let's just try going real old school, and let's write this down as what they are. Tangent is sine over cosine, cotangent is cosine over sine, put the x's in there. And let's combine the fractions, go back to like old school ways of doing things, like 1 plus, I don't know, 3/8. Well, we have to multiply that 1 by an 8 and that 3 by the understood 1 there. And then we can put things together. Now, if I multiply the top by 8, I multiply the bottom by 8. So anyways, I need to go back to that train of thought. So I'm going to multiply this 1 by that cosine. So I'll have cosine of x. And if I do it to the top, I also do it to the bottom, because cosine of x over cosine of x is 1. So plus sine of x over cosine of x. Do the same thing down low. This becomes sine over sine, which is 1. Then plus cosine of x over sine of x. What I'm doing is I'm unifying the fractions. This one is going to become cosine plus sine over cosine of x. It's all going to be over sine plus cosine, sitting pretty over sine of x. Now, to divide one fraction by another, we multiply by the reciprocal. And by the way, cosine plus sine is the same as sine plus cosine. And there's simplification and stuff goes on here, but anyways. I'm going to leave this one away. I'm just going to rewrite it as sine of x plus cosine of x because it'll make the next move more obvious. And I'm going to flip this one. It's going to become sine of x over sine of x plus cosine of x. And these guys are the same. In multiplication, we just merge, right? They cancel. So I'm left with sine of x over cosine of x, which is tangent of x. All right, number 2 is something I have not done with y'all. It's coming, and they're not hard. It's just a good time to introduce it. And a basics quiz is actually a perfect place to introduce it. So let's look at what this thing is asking us. It says, find if y is the secant of the arc sine of 1/2, what is y? All right, so if we just focus on this piece right here, this guy in the middle, that says, what angle has a sine ratio equal to 1/2? Now, there's lots and lots of ways of doing this. Lots and lots of ways of doing this. If you think about the unit circle, you can pick that up pretty quick. It's asking where is y equal to 1/2? So on a unit circle, that's 30 degrees, right? If you go back to geometry, you go classic triangle trig, and you just draw a right triangle. You think about the sine ratio. We'll just put an angle here. And the sine ratio being opposite over hypotenuse, you'd have a 1 over a 2. And what you're supposed to do is you're supposed to have memorized your 30, 60, 90 patterns. And you're supposed, because, if you think about your 30, 60, 90s, 30, 60, 90, it's going to root 3. You're supposed to realize, hey, that this is 30 degrees, all right? So anyways, you would fill out the rest of the triangle. And either way, you kind of need that pattern to do this problem to some degree. So let me go back to the unit circle. If I'm a fan of the unit circle, and I realize that I'm right here at 30 degrees, where the ordered pair is root 3 over 2 and 1/2, and I have an understood radius of 1, remember that. I made you guys memorize this, but the secant of an angle is defined as the radius over x. That's what it is. So the radius of the unit circle is 1, and the x-coordinate here is going to be root 3 over 2. So we're going to divide by a fraction by multiplying by its reciprocal. This becomes 2 over root 3. we clean up with a root of 3 over root of 3, and we get 2 roots of 3 over 3, which is the answer. Now, also, if I'm a fan of the classic triangle, and I have this pattern drawn out, I know that the secant of an angle is the funny guy hypotenuse over adjacent. And I would get the same thing, 2 over root 3, multiply top and bottom by root 3. Either way you do it, you get 2 root 3 over 3. You need to pick your poison. Are you the red pill or the blue pill? Pick it, go with it. All right, solve e to the 2x plus 4 equals 5e to the x. Looks kind of like a scary little problem to some degree, doesn't it? I don't know what the best way of doing this one is. Pause for that second on that one. Give me a sec. So the author of this particular question is kind of a jerk. It'd be really cool if you got to use a TI-84 on your challenge exam, but you don't. This is a higher level question because I don't know a way to solve it algebraically. I know how to get the answers, and it requires a lot of thought. From your end, here's something you can do. And I won't put anything this hard on your actual, I'll do something, but I'm not too happy with this particular question. You can plug things in. You're just going to have to know things. So if you do e to the 2 times a 0 plus a 4 equal to 5e to the 0, well, this is e to the 0, which is 1. And this is e to the 0, which is 1. And 5 is equal to 5, so that's a true answer. The other answer happens to be the natural log of 4. E to the 2 ln of 4 plus 4 equals 5e to the ln of 4. Now, this is a property that is going to make a lot of y'all struggle. And I'm trying to think if there's any good way to explain it. And there's really not. I mean, I know what e to the 2 e to the 2 times ln of 4 is, but I don't know how to explain it to you. Like I said, I'm not happy with this question. It's 16. I wish that this example was set up different so I could explain the property better. But in essence, the e's cancel. And remember that things out in front of a logarithm become powers. And it kind of just drops down to 4 squared plus 4. Now this guy, the e's kind of cancel to some degree. And we're just left with the 4. 5 times 4. It's 20 equals 20. Again, I'm not going to put anything this bad on your test. It's not a good question. It's a good question for like a math contest. But even then, they'd let you use a TI-84. It's a horrible question for a challenge exam. I'm not sure why the author did that. I didn't come up with this question. Not a good question. Don't like it. I do like the fourth one. Expand this logarithm. It's 1 over 10x squared y. And we have some properties here that talk about logarithms. If you take a logarithm, and I'm going to put 4 elements in it, AB over CD, it is a log of A plus a log of B minus a log of C minus a log of D. So the division is becoming subtraction. So I'm going to expand this log. I'm going to have a log that contains a 1. Take away a log that contains a 10, because there's a 10, because there's 1, 2, 3, 4 parts of this logarithm. Take away a log that contains an x squared, and then take away a log that contains a y. Now, I have asked y'all to memorize things like this thing, and by the way, this is just log, so it's an understood 10. This is saying what power of 10 equals 1, and the answer to that is 0. That is a 0. If you have a 1 inside a logarithm, it's a frickin' 0. Same context here, this one becomes a 1. We are allowed to move exponents out front, so this becomes minus 2 logs of x, and then we have minus logs of y. So I'm looking for this, negative 1 minus 2 logs of x minus log of y. It wasn't that bad. Good problem. All right, to what does secant minus cosine of x simplify? Now let's find out. It's going to be 1 over cosine of x minus cosine of x. And what we're going to do is we're going to introduce cosine of x down here. And if we do that, we have to do it to the top. So it becomes 1 minus cosine squared of x, both pieces over cosine of x. And you know, what is 1 minus cosine squared of x? So the main Pythagorean identity that you remember is sine squared of x plus cosine squared of x is 1. So if I subtract the cosine squared of x, sine squared is 1 minus cosine squared. So this becomes sine squared of x, sitting pretty over cosine of x. Now, if I break the sine of x apart, I can see this right here, and that is tangent of x. So I have tangent of x times sine of x. There we go. Easy peasy lemon squeezy. 6 is a calculator problem. I'm going to let you use a calculator on this basics quiz. It's not a hard problem. It says, given the indicated parts of a triangle ABC and C is 90 degrees, find the exact or approximate values of the remaining parts. So you should probably draw a triangle. You don't have to, but you probably should. And they told me C was the right angle. Little a is opposite of angle A, and it's 0.32. Little c is opposite of side C, and it's 0.71. And you can do Pythagorean theorem to get this side down here, right? X squared plus 0.32 squared is 0.71 squared. I'm hoping it's something like 0.43, but it's probably like 0.63. It should be 0.43. So anyways, 0.71 squared minus 0.32 squared is that. Square root of that, 0.63. All right, so little b is 0.63. Going. Now, what's the angle? I don't really need trig to figure out the rest of this problem. You can actually just fall back on something old school. The bigger the side, the bigger the opposite angle. All right, so I noticed that angle B is opposite of 0.63 and angle A is opposite of 0.32. Angle B is bigger than angle A. That is a given because it is a bigger side. So it's got to be choice D. Now, if I don't trust Milbrath-Math's logic, I can use some trigonometry. If I focus my attention maybe on angle A, I can say, okay, I have opposite and I have hypotenuse. The sine of A is 0.32 over 0.71. That means that A is the arc sine of 0.32 over 0.71. And then I can go pushing buttons. Put my TI-84 in degree mode. Arc sine 0.32, sitting pretty over 0.71, 26.78 degrees. So, right choice was made. 7, determine any vertical and horizontal asymptotes for f of x equals blah, blah, blah. Your vertical asymptotes happen when the denominator equals 0. So x squared minus 1 is a nothing, x squared is a 1, x is plus or minus 1. So, choice A. Well, sorry, it also wants horizontals, doesn't it? Choice A has the verticals, all right, but the horizontal asymptotes. I've said this hundreds of times, horizontal asymptotes are found with long division or memorization. And there's 3 rules about horizontal asymptotes that you can memorize. But anyways, you can always do long division. Always. This one's just going to be 1. So how do I turn an x squared into an x squared? Or how many times is x squared enter x squared? Then there's 1 time. And then I invoke the distributive property. X squared minus 1. Wrap and subtract. X squared minus x squared is 0. 4 minus 1 is minus a negative 1 is 5. And I have to carry down the 4x. Can I turn x squared into 4x? No. It's done. This is the horizontal asymptote. It's y equals 1. So choice E. 8 will be a lot like one of the ones we did earlier. This says evaluate the arc cosine of the sine of 5 pi over 4. Kind of an interesting little problem there. Evaluate the arc cosine of the sine of pi over 4. All right, so now arc cosine is going to return an angle. Thankfully, the author of this question didn't put a side length in. They should have. But arc cosine returns an angle, which is what you have. So let's figure out the sine of pi over 4. So we'll probably do that by thinking about the unit circle. We just think about the unit circle, and we think about 5 pi over 4. And here's something that we haven't done yet, so it's a good place to start talking about it. 5 pi over 4 is going to be right there. At least I believe it's going to be. And you're going to have root 2 over 2 and root 2 over 2, and they're both negative. And you might think, well, why isn't the answer 5 pi over 4? Because this is where I'm at. But anyways, the sine of pi over 4 is negative root 2 over 2. So now it's asking you to do the arc cosine of negative root 2 over 2. And this is where trig gets kind of tricky for a lot of kids. I didn't do this, okay, so don't hate me. Arc cosine only returns angles in quadrants 1 and 2. See, you're not allowed to have a TI-84. If you were, you'd be in business, because this would be a super easy problem. So now it becomes, where is x, negative root 2 over 2, in quadrants 1 or 2? And the answer is right there at 135 degrees, or 3 pi over 4. I know that seems funny, and it'd be so wonderful if you got to use a TI-84 on your challenge exam. But if you hit second cosine of negative root 2 over 2, and I'm already in degree mode, by the way, it's going to say 135 degrees. If it's there, I wasn't lying to you. Evaluate the tangent of the arc cosine of 3/5. So, pay attention to the fact that this is a positive value, which means that the angle lies in quadrant 1 or 4. But again, arc cosine is only good for quadrants 1 and 2. So what we do is we just draw a triangle in quadrant 1. And this was not a unit circle problem. I wish it was, it's not. Anyways, we just put theta in the corner. Cosine has always been adjacent over hypotenuse. So 3 and a 5. Unless you're a little slow, you are aware of a 3, 4, 5 special pattern. And now I can find the tangent of this angle. So the tangent of the angle would be opposite over adjacent. Opposites of 4, adjacent to 3. Winner, winner, chicken dinner. And it'd be cool if you got to use TI-84 because you just push buttons on that and it would tell you 1.33333. But you can't. Solve 2 sine squares of theta minus 1 is nothing. This is a super easy problem. 2 sine squares of theta is going to be 1. Divide the 2 out. Sine square of theta is 1/2. So the sine of theta is plus or minus the root of 1. It's a bad looking 1. Over the root of 2, which cleans up to be plus or minus root 2 over 2. So I'm asking here, where on the unit circle it's interesting that they did not include all 4 answers. Is y plus or minus root 2 over 2? The author of this question has made a mistake. I don't know why they did it, but they did. The best choice that is presented is this one. There should be a couple more answers, or they should have restricted it to pi. But it's at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And again, I'm not sure why they didn't do it right, but they didn't. Shame on them. The expression I to the 32nd plus I to the 18th is equivalent to which of the following? So let's go over your i's. We know that I is the square root of -1. We know that I squared is 1. We know that I cubed is -I. And we know that I to the 4th is 1. That's what we were supposed to memorize a long, long time ago. So focus on this. I to the 32nd is I to the 4th written 8 times. I to the 18th is I to the 4th written 4 times, followed by an I squared, because 4 times 4 is 16, plus 2 is 18. 4 times 8 is 32. And I to the 4th is 1. So this just becomes 1 to the 8th, which is 1. 1 to the 4th is still 1. And then times I squared, which is also 1. And no, sorry, I squared is -1. I almost made a mistake there. So it ends up being 0. Survey at point C is 9.4 kilometers from a surveyor at point B. A third surveyor is at point A. If angle B is 43 degrees and angle C is 64 degrees, how far is the surveyor at point C from the surveyor at point A? So we've got 3 surveyors. We have some angles between them. Looks to me like we're talking about a triangle. It doesn't really matter how you draw it, I don't think. Oh, and I'm assuming it's a right triangle. I shouldn't assume that. Surveyor at point C is 9.4 kilometers from a surveyor at point B. A third surveyor is at point A. If angle B is 43 degrees and angle C is 64 degrees, how far is the surveyor at point C from the surveyor at point A? So you are well aware that there's 180 degrees in a triangle. So the measure of angle A is going to be 180 minus 64 minus 43. 107. 73. Now, this is not a right triangle. Okay, so there's no SOHCAHTOA. We're not using it. We're going to do what's called law of sines. And I'm so tired I can't even remember if I've done law of sines with you yet this year. But I know I did it in algebra 2. Law of sines says the sine of A is to side A as the sine of B is to side B. So the angle A is 73 degrees. The sine of 73, and this is also a geometry standard, is to 9.4 as the sine of 43 would be to little b, side B. And then we do some cross multiplication. Oops, I did not mean to do that. 9.4 sines of 43 is equal to b sines of 73. We just divide both sides by the sine of 73. This could be on your challenge exam because the truth is this is the legit answer. It is the answer. And they can put stuff like this on the challenge exam. It's not that big a deal. Let's see what it is though. 9.4 sines of 43 divided by the sine of 73. 6.7. Choice B. All right. These are questions that I know fit your challenge exam super well. Write the equation of g of x, which is obtained after the following transformations are applied to f of x equals x cubed. The graph is shifted right 5, so right we're going to do opposite. Inside we're going to have x minus 5, and it is a cubic. Vertically stretched by a factor of 2. This is a, that goes out front, and then down 3. There you go. So if you're curious about what I did, I used this transformation form AF's of b times x minus h plus k. And b is horizontal. It wasn't mentioned. So I just used that. And I plugged stuff in. And that's it. Difference quotient's up next. Let's do this piece first. Find f of x plus h. Means that every single x you see becomes x plus h. And this one's squared, so I'm going to go ahead and write it twice. I think about half of you guys are getting it so far. So I did the distributive property here, and xh plus xh is going to be a 2xh. And then I'm going to do the distributive property here again to that guy. I'll have 3x squared plus 6xh plus 3h squared minus 7x minus 7h. Now I'm going to insert this part. It says take away the original function. So take away, use your parentheses, 3x squared minus 7x. I'm also going to insert that piece all over an h. Now, if it's on the inside, it's on the outside, and it cancels. That's how it is. If it's on the inside and it's on the outside, it cancels. That's just how these are. You do this a few times, you'll get that. But you got to do it a couple times. So we have 6xh minus 7h, I like to change the order here, plus 3h squared, sitting pretty over an h, and there are 4 terms here, and every piece contains a common factor of h, so I can divide it out. And I'm left with 6x minus 7 plus 3h's. And there's a shortcut to this too. Like, it's here. There is a shortcut. It's a huge shortcut, and God, I want to teach it to you. But, like, stare at this, and then stare at this, and see if you can come up with the shortcut, because it is there, man. It is there. There is a shortcut to this. Anyways, the radioactive element carbon-14 has a half-life of 5,715 years. If a piece of charcoal from an ancient campsite has 20% of its original amount of carbon remaining, determine its age. Valid question for your challenge exam. And you might think that you need a TI-84 to do it. You don't, because they'll present the answers in a form where it is what you would finally put into a calculator. So your half-life formula is the principal times 1/2 to the T over half-life. That's the formula. They don't give it to you either. You have to know it. The principal here would just be 100%, and it would equal 20% after some time has passed. The amount after time becomes 20%. The principal is 100. We have our 1/2. We have our time, which is unknown, over the half-life of 57,000 or 5,715 years. First thing we do is we play the isolation game. We divide out the 100. 20 over 100, they might use 0.2. They might use 1/5. It doesn't really matter. I'm just going to use 0.2 because I think the author of this test will probably use 2/10. So 2/10 equals 1/2 to the T over 5,715. Now, the real question is, they're probably going to use LNs to represent your answer, but we'll get there in a second. We have an answer, we have a base, and we have an exponent. Log is big. The log of a base of 1/2, whose argument is 2/10, is equal to T over 5,715. Now, I'm going to do something here because I know how they do things. I'm going to make this guy a natural log using what we call change of base. This becomes the natural log of 2/10 over the natural log of 5/10. And that's still equal to T over 5,715. To isolate that T variable, I multiply both sides by 5,715 because I'll have a cancellation. And if I do it to the left, I do it to the right. And there's my answer. 5,715 natural logs of 2/10, sitting pretty over the natural log of 5/10. All right, moving forward, 16, we have average rate of change. The formula for average rate of change is F of B minus F of A, sitting pretty over B minus A. It is also Y2 minus Y1 over X2 minus X1. They are the same formula, all right? If you want to know your Y values, you plug things in, right? That's what you do. Anyways, the bottom here is going to be 5 minus 0, which is going to be 5. And I'm going to have to plug a 0 in. Okay, so F of 0 is 8. And let's see, that was A, so minus 8. And I'm going to have to plug a 5 in. Big whoop. I'll have a negative 5 that is squared. I'm not squaring a negative 5. I have a negative 5 that is squared, which is negative 25. Plus 3 times 5 is 15 plus 8. So that's going to be negative 10 plus 8, which is negative 2. So negative 2 minus 8 is negative 10. Negative 10 over 5 is negative 2. There's your average rate of change over the interval A to B. What do we have here? For triangle ABC, it is known that angle C is 90 and A to B is 12 and B to C is 5. Find and state the exact length of segment AC and the exact measurement of angle A. This is not a 5, 12, 13, by the way. So let's find this little side first. A squared plus 5 squared is 12 squared. A squared is 144 minus 25. A squared is 121. Is it really? No. I'm slightly retarded this morning. 119. So A is the root of 119. Now, how do you find the measure of angle A? You do that with trig. it's a right triangle, I would go here and here. The sine of angle A is 5/12. So the exact measurement of angle A is the arc sine of 5/12. Not pushing buttons, because again, you're not supposed to. That is the measure of angle A, the arc sine or the inverse sine. Two fire lookout stations are 13 miles apart, with station B directly east of station A. Okay, so we're going to put A at the origin. Station B is directly east, and the distance between them is 13 miles. Both stations spot a fire. So there's a fire somewhere. Okay. The bearing of the fire from station A is north by 35 degrees east. So north by 35 degrees east. The 35-degree angle is actually right here. The bearing of the fire from station B is north by 49 degrees west. Now, so here's north. This is one thing about bearings. For bearings, we always form the angle with the north-south axis. That's how we do it. It's just the way it's done. All right? Sorry. Anyways, I know that this is a right angle, and I know that this is a right angle. So if I do 90 minus 35, I feel like I get 55. And if I do 90 minus 49, I feel like I get 31. So inside my triangle, this is what I actually have. Now, I want to know how far the fire is from station B. So that's my unknown right there. I know, and you know, that every triangle in existence has 180 degrees. So this angle right here is going to be 180 minus 86, which is 94 degrees. Unless I'm making a mistake somewhere. I'm pretty shot. Earlier I used law of sines. I'm going to do it again. The sine of this 94-degree angle has to compare to 13 as the sine of this 55-degree angle compares to x. Then we cross multiply. X sines of 94 equals 13 sines of 55. And x is therefore 13 sins of 55 divided by the sin of 94. And there you go. There's your answer. Two more to go. Express the domain of the function f of x equals the root of x plus 5 over x minus 6 using interval notation. So there's two rules here. You have this rule, for the square root of anything, anything is greater than or equal to 0. And then you have this rule. For 1 over anything, anything is not 0. There's our rules. All right. Turns out that if you blend these rules, if you blend them for this problem, you just get that anything is bigger than 0. Well, maybe. I don't know. We'll see. Actually, we're not going to blend them at all. So let's take a look at this one. X plus 5, it is supposed to be greater than or equal to 0. So x is greater than or equal to negative 5. All right, because I think the denominator might trump this. We'll see. X minus 6 is not allowed to be 0, so x cannot be 6. Okay, we're good. We just have to kind of think about this on a number line here. Here's negative 5, and I'm allowed to go all the way over here. But then I encounter something at 6. I encounter an open hole. So I get to go to the open hole, and then I jump over it. So if I'm using interval notation, I get to be from -5 to 6, can't be 6, use parentheses, union with 6, and I get to continue on forever to infinity. So ignore my ideas of a blending thing over here. I'm just tired. Just sit down and crank out the pieces and use that God-given brain of yours and THINK. Last one, find the center and radius of a circle given by the equation x squared minus 8x plus y squared plus 16y plus 7 is nothing. You're just going to do the complete the square method here. So take half of that number. You get, I don't know why I divided by 4, but -8/2 is -4. Square it, and you get 16. And you add it here, and you add it here. You add it to both sides. And by the way, this guy belongs over here. Start focusing on the y's. I encounter the b term. Take half of it, I get 8. Square it, I get 64. Add it to both sides. The right-hand side is going to be 73. This factors as x minus 4 twice. Oops. X minus 4 times x minus 4. This factors as y plus 8 and y plus 8. So if you write something twice, you may have, well, just written it once as a square. All right, now, STD form of a circle is x minus h quantity squared plus y minus k quantity squared equal to r squared, lineup process. Your center, hk, is going to be at 4, -8. And your radius is the root of 73. Because r squared lined up with 73, and the opposite of squaring has always been square rooting. So there you go, pre-calc kids. That's what your next basics quiz looks like. Later.